Okay, so here is the next question. So it's about the limit of a function of two variables. And to be honest, I find this question quite challenging. And I think it's a bit cruel to give such question to students on a final exam. I mean, it's like, I don't know, maybe I'm not thinking clearly, but I think it's, well, I just spent a few minutes trying to figure it out. And the only solution that I came up with is it is pretty tricky. And to be honest, I'm not even sure that I would be able to do it on an actual exam, because on an actual exam that there is a lot of other questions, and it probably there may not be enough time to think deeply about this. Okay, now let me explain. So what my logic is behind this question. So my idea is that so here we have a numerator and denominator. So and sine, x y approaches 0 0, right? So you can think of x and y as being very small numbers, and we know that sine of a very um, uh, small number approximately equals to that small number, right? So sine of x is approximately equal to x for small values of x. So which means that this whole thing is when x and y go to 0 0 is approximately the same as x squared times x times y squared, right? So you can just get rid of this sign. But then without this sign, the numerator is going to be a polynomial of degree 5, right? So it's going to have x cubed times y squared. But the denominator is going to be a polynomial of degree 4. And 5 minus 4 is 1. So the overall kind of fraction, it behaves like a polynomial of degree 1. So which means that at 0, its a limit should be 0, right? Because it's something like x. So the whole thing is something like x when x is very small. So its limit should be 0, which is why here we're going to try to prove that the limit is 0. So that's the intuition behind it, right? So let me now do it formally, right? So the limit as x y goes to 0 0, x squared sine of x times y squared divided by x to the 4 plus 9 times y to the 4. Now, as I said, we're going to prove that the limit is 0. And basically, the only kind of tool that we have is the squeeze theorem, right? So we're going to use the squeeze theorem. Well, and in order to prove that um, the limit is 0 is the same thing as to prove that the absolute value of the whole thing has limit 0, right? So we can kind of use the absolute value, right? So for the absolute value, we have this 0 is less than or equal than the absolute value of this thing, x squared times sine of x y squared divided by x to the 4 plus 9 y to the 4. This is less than or equal. So now I'm going to use one very useful inequality, right? So the very useful inequality is that sine alpha is less than or equal than alpha itself, right? Well, for absolute values. Okay, so I'm going to estimate sine of x y squared with x y squared itself without the sign, right? So this is less than or equal than x squared times. Now I'm estimating the sine of xy squared with x times y squared. X to the 4 plus 9 y to the 4. All right, and this thing is really, x squared, y squared is really non-negative, so we can get rid of the absolute value sign. So this whole thing becomes less than or equal than absolute value of x times x squared y squared divided by x to the 4 plus 9y to the 4. All right, now look at the question. So what are we going to do with um, x squared y squared divided by x to the 4 plus 9y to the 4? Um, well, basically we want to kind of estimate it, and to be honest, I'm not very sure how to explain my intuition behind it. Maybe it's just because I don't know. Maybe I have this intuition because I've solved a fair share of Math Olympiad questions in my life. I don't know, but here is kind of my approach, right? So I kind of want to relate x squared y squared and x to the 4 and y to the 4, so which kind of comes from squaring something like x squared minus 3y squared. Because if you square this thing, then you will get x to the 4, you will get 9y to the 4, and you will get um, x squared y squared, right? So this is really x to the 4 minus 6 x squared y squared plus 9y to the 4. On the other hand, this is the square of something, and the square of anything is always non-negative, so it is non-negative. Now I'm going to move this thing to the right hand side. So this inequality is equivalent to saying that x to the 4 plus 9y to the 4 is bigger than or equal than 6x squared y squared. Right? But this is kind of already very close to what we really need, right? So, but we here we have a ratio of x squared y squared divided by this, right? So how do we construct such a ratio? So we can just divide by x to the 4 plus 9y to the 4, right? Because this is a non-negative number, so we can divide by, well, strictly speaking, it should be a positive number. It can't be 0. So because it can only be 0 when x is 0 and y is 0, but that's precisely what we are looking is the point of the limit. Okay, so now we are going to divide this inequality by x to the 4 plus 9 to the 4. And doing that, we will get 1 is bigger than or equal than 6x squared y squared divided by x to the 4 plus 9y to the 4. So, and then basically kind of switching the left hand side and the right hand side and dividing by 6, we will get x squared y squared divided by x to the 4 plus 9y to the 4 is less than or equal than 1 over 6. Okay. Right, so this thing is less than or equal than 1 over 6, so the whole thing is less than or equal than absolute value of x divided by 6. So now, as x and y go to 0, 0, 0 approaches 0, and this thing approaches 0. So by the squeeze theorem, the limit is 0. But again, so as I said, I think it is pretty tricky. So it's not really immediately obvious how to do it, and I myself spent probably 5 or 10 minutes trying to figure it out. So it's really not easy.